Okay, warm-up is going to be the puzzle time. I want you to spend some time on it. We're not going to spend tons of time on it, but get going, work together, talk with your neighbors. Okay? Okay, I'm going to go through 1 through 4 with you right now, and then we will pause on that. But number 1, determine whether the equation represents an exponential function. That is a yes. Definitely a yes, because we have the exponent up here. Number 2 is a no. Even though we have the x up here, this is a negative. Okay? And you can't have a negative when you're doing an exponential function. If you were to graph that, the picture that would look like, let me put it on here real quick. Then okay, so if I am graphing that first one, number 1, it looks like that. Okay, and let me zoom in just a bit here. But you kind of see the slide shape. Okay, that's the exponential function. Whereas if I have the other graph, does not do as well here, and I actually have to zoom out to get to it. So that other one's going to bounce up and down. I can't get it to show up, but what ends up happening is when you put in 1, you get negative 11 times 6, which is negative 66. Then you put in 2, you get a positive. And it's a huge number. So the graph starts doing this zigzag thing. Okay? So this is a no because of that negative sign right there. When you raise a negative to an even power, you get a positive. When you raise it to an odd power, you get a negative. So it starts bouncing up and down on between the positive and negative values for y. That one's a no. Number 3, yes or no? Yes, you're multiplying by 5 every time here. And you're adding a constant amount on top. Whereas number 4, you're adding a constant amount on top. But are you multiplying on the bottom? No, you're adding. That makes it linear. Not 24, but 4. Okay? So this one's linear. This one is exponential. Okay, when you multiply, you get exponential. When you're multiplying by a constant amount each time for your independent variable, your y variable. When you're adding a constant every time, you get linear. Okay, I'm going to do one of these, number 5 here to begin with. We're going to plug in. We're going to evaluate the function for the given value of x. Here's our given value. We're going to put that in for x. So we're substituting in. So we get y equals 4 to the negative second power, which should be 1 over 4 to the second, which is negative 1/16. Okay. It is. Oh, I'm sorry. Positive 1/16. Thank you. Way to check me there, Quinn. Positive 1/16. Letter F. Okay. So I'll give you guys the opportunity to work a little longer on that.
Or motorcycle. Train motorcycle.
Train motorcycle.
That'd be something to see.
Make sure you always do the squaring first, or use the exponent first, and then multiply by that number on the outside. About negative 136, negative 36.
What I got so far is FLLW bits tax. See if I can follow its track.
Now remember, when you get that fractional exponent, that means the cubed root of 27 all squared. The cubed root of 27 is 3. And 3 squared is 9. So we get 1/9 of 9, which is 1. All that's just to get 1. Okay, number 11. Hey, if we're finding the domain and range, this graph right here, if we ignore the plus 3, our picture for these types of graphs, if it's a positive value out in front of your power there, that graph is doing that. It's going upward. It's approaching 0 on the y, or it's approaching the x-axis, which is y equals 0. Well, we're taking that graph and we're adding 3 to it, which means we're moving it upward 3 units. So I would have to take kind of that sketch I have there and then start moving it upward 3 units. So rather than approaching 0 on the y-axis, I would now be approaching 3 on the y-axis. But never hitting it, right? So that would mean my domain is still all real numbers, but my range is now y is greater than or equal to 3. Remember, this is our k term from earlier in the year when we started talking about vertex, okay, and our shifts. Greater, oh yes, greater than 3, not greater than or equal to. Can't be 3. Thank you. Y is greater than 3. No, I don't know. Maybe. All right, this one right here, this is shifting you left and right, so it would be taking that graph and moving it horizontally. So rather than, if you had this originally, thank you. If you had that, it would actually move this point to the right 4 units. Okay, that's what that's saying right there. So it's not affecting up and down, so it's still y is greater than 0. That's my domain. Or excuse me, that's my range. And my domain would be all real numbers still. Okay, how does my range change on number 13? Goes down 8, yeah. Domain stays the same, all real numbers. Whereas my range is now, y is less than, or excuse me, greater than negative 8. Greater, oh. That doesn't, we have our negative 8. Oh, yep, because we got a negative out there. Thank you. Yeah. Okay, and this one right here, domain, all real numbers, and range is y is greater than negative 1. Okay, the function 3 times 2 to the x represents population of beehive, where x is the number of bees. Okay, or x is, the number of days. How many bees in the hive after 4 days? Put the 4 in right there. That's 2 to the 4th, which is?
What do you? Well, that's the final answer.
Yeah, that's the final answer. Okay, 2 to the 4th, I believe, 16. Times 3 is 48. All right. Very good. Any questions? Take that extra practice out from yesterday. You're supposed to do 1 through 11. Okay, so our page 181. I'm going to put up our answers and we can talk about questions. But hey, notice on number 1, we're adding 1 and then multiplying by a half. Therefore, this is exponential because as x increases by 1, y multiplies by a constant. Number 2, you're adding 1 for x, adding 4 for y. It's linear because as x increases by 1, y increases by a constant. It's not multiplying, it's adding. Therefore, it's linear. Number 3 is also linear because as x goes up by 1, y is going up. It's adding 3 each time. Versus number 4, which is exponential because as x increases by 1, y is multiplying by 4. So tell your neighbor how you know the difference between exponential and linear when you're looking at a table. Okay, guys, so for linear, what are we doing? Yeah? Adding or subtracting. And exponential, what are we doing? Multiplying by a constant. Okay. Number 5, and 6, and 7. Evaluate for the given value of x. When you put 5 in, you get 243 out. When you put 3 in for x, you get 164th out. And when you put 4 in for x, you get 768 out. Questions on those 3? Okay, number 8 and number 9. Notice I don't have my table of values up here, but you created the table of values. Hopefully you get a picture. It looks something like this. Notice this one's opening downward. Okay? It's opening down because we have this -1 hanging out in front of it. All right? Hi, Sarah. Yeah. This is a reflection over the x-axis. That's what happens when we're multiplying on the outside there. And number 9, you get 2 times 1/4 to the x. These numbers become very, very, very small when you're building your table. Okay? But this would be 8 up here at -1, 2 at 0, 1/4 at 1, or excuse me, 1/2 at 1. Okay. What's that? I didn't hear. Yeah, the domain here, all real numbers, the range, y is greater than 0. This is more of a note page on it. Okay. Yes, Jill? Right, so your that is probably 1/64. If you're using your calculator and you don't know how to change a decimal to a fraction, then just go to Math, Option 1, which is fraction, and hit Enter. Okay? Number 10. Number 10, notice this, just based on what we did on our warm-up today, this tells us we're shifting the graph down 2 units. Okay? So if I'm going up by 2 here, actually, I think I went up by more than that. Am I going 2s? Okay. Okay, I'm shifting it downward 2 units. So rather than being at 1, I'm at -1. Okay? And this one, I'm actually shifting it left or right 1 unit. But the domain is all real numbers. Range is y is greater than -2. Domain here, all real numbers. Y is greater than 0. Okay. How many of you remember the format from earlier in the year where we had We talked about this a bit. F of x equals x minus h plus k. How many recall that? Okay, h was a horizontal shift. Okay, it moves it left and right. Horizontal translation. K is a vertical translation or shift. So it moves it up and down. So this is going up, down, left, right. Remember, this one's always backwards. So if it says minus, it's actually going to the positive side. And if it's plus, it's going to the negative side. Okay? But this right here, that one's with the x. So this actually took this graph and it moved it 1 unit this way. So this would have originally been our where it crosses, but it moved it 1 over. Okay, this one shifted it down 2 units because it's on the outside. Okay, so what I want you to do right now, I want you to take a look at number 7 and, or excuse me, not 7 and 8, but number 13. Number 12 and 13. And go ahead and work on those 2 problems with your groupies there. Okay, there are 2 places you need to fill in. These are the 2 places. Y equals A, B, X. You need to fill in A and B, at least A and B on these. So you need to figure out what A is and what B is. That is the general form. Like y equals mx plus b is linear. When you're dealing with exponential, it's y equals ab to the power of x. Okay? Y equals ab to the power of x. It's a good question. What is A? Hey, to help you out here, let's look at some graphs you've already done. What is A in this one? I'll rewrite the equation. Y equals -1 times 2 to the power of x. What's A? A is -1. What's B? 2. Okay? All right. Let's go to this one. Y equals, oh, you guys have it there. I'm not going to rewrite it. Okay, what's A? 2. What's C? Or what's, excuse me, A is 2. What's B? 1/4. Okay? So, looking at these 2 graphs, try to figure out, hey, A shows up where on my graph? Where does B show up on my graph? Try to make that connection there. Where does A and B show up on your graphs? Talk about it then. Any ideas? Jill? Good, yeah. Like on this one here, the 2 is my y-intercept. Does that work over here? Is my A my y-intercept? Yeah. Just so happens that A is always your y-intercept. Okay? With one exception, when you change the value up here, if you're adding or subtracting to the x in there, because then it's shifting it horizontally. Okay? Okay, but A is generally your y-intercept unless you're putting something in here with the x. Like if you had x minus 5, then it wouldn't be. Okay? And the B you said was your slope, kind of? Yeah, it's kind of your slope. It's your rate of decay or your rate of growth. Like on this one, I'm going down by 1/4 every time. So this point right here, that's at 8. This one's at 2. 1/4 of 8 is 2. Then 1/4 of 2 is 1/2. And then 1/4 of 1/2 is 1/8. Okay? So that's kind of I mean, if you kind of trying to relate it to what you already know, you may think of it as slope. It's not really what we call it, but yeah, it's your decay rate there. So when I'm looking at this, what's my y-intercept on number 12? It's 3. It's when x is 0. What am I going up or down by? Yeah, I'm multiplying by 6 because up here I'm adding 1. So my b is 6. So my equation is 3 times 6 dx. So either put a multiplication symbol or parentheses. So on this one, we're actually looking at the picture. What's A? Tell your neighbor there. Negative 0.5, well done. And what are we going down by? So we go from negative 4 to negative 2 to negative 1. Divided by 2, cutting in half, yeah, looks like a half. So y equals negative 0.5 times 1/2 to the x. Make sure you put that 1/2 in parentheses there. Okay, now we've made one little mistake on this. Did anyone catch it? Kind of let us carry through on it. Oh, we got the, no, it's not negative 1/2. Yeah.
Will we ever need to find the x?
No. Well, you have to look at the x values. Yeah, that's a good, you guys, hey, notice, what are we going up by on x here? 1. What are we going up by here?
Not a continuous.
Not 1, are we? So it has to be, in order for us to be able to find our b appropriately, this has to be going up by 1s. We're not. We're going up by halves. So if I start at 4 and I want to go up by 1s, my next point would have to be what? Or excuse me, if I start at negative 1/2, so let's put it in a table real quick. If I have x and y, negative 1.5, negative 4, negative 1, negative 2, negative 0.5, and negative 1, and then 0, and negative 0.5. Okay, so I have my table. I am not increasing by 1. I'm increasing by 1/2. Okay, if I want to increase by 1, I'd have to get rid of those. What am I actually, what's happening here? Yeah, we're multiplying by 1/4. Okay, because you've got to, this has got to be an increase of 1 in order for us to find the correct rate. That would be 1/4. That's all right. No one caught it, but hopefully we understand. Make sure you make a note of that. You have to be going up by 1. Okay, if you're looking at it in table format like that. Okay. Hey, we are going to use our graphing calculator on number 14. Everyone needs a graphing calculator.
Okay.
Okay, so remember, if you're using your graphing calculator, it may be helpful to clear the memory verse first. So second plus 7, 1, 2. Okay, we're going to go to our y equals menu. So recall, that's up here. We're going to put in the function they gave us, f of x equals 2 to the x. Remember that f of x is the same thing as y, so we go 2 to the power of x. So use a little up arrow here. Okay, your little caret symbol right here. And then raise it to the power of x. Remember our variables right here. Okay, and I want to hit graph there and just see what that picture looks like. There, we've got it. Okay. And then we are now going to graph this same one. G of x is also the same thing as y. So this one was our y sub 1. This is our y sub 2. Okay? g of x equals 2 to the power of x plus 3. So we're going to go in here to y sub 2. We're going to go 2 to the power of x. And then I'm going to arrow over, so out of that area where the exponent is, and plus 3. Any ideas on what that's going to do to your graph?
It's going to move it up 3, but I don't know that is the same.
Oh my gosh, there it is.
Good. So like it moves it up 3 units. Now you can double check that by using the table feature. What's our y-intercept here, by the way, on this equation? What's our a term? It's not 0.
Oh, yeah.
And it's not 2. That's our b term.
Anything greater than 0.
Yes, it's 1. If you don't see it, it is 1. That's our b term in both of those. Okay? Or excuse me, that's our a term in both of those. That's a. That's b to the x. That's a, b to the x. Notice we are adding 3 to what our a term was, which means our y-intercept started here at 1, and then it moves to 4 here. We add 3 to it. Okay? If we were to look at our table feature, so second graph, and see when x equals 0, when x is 0, y is 1 in our first equation. Our y-intercept's 1. In our second one, it's 4. Notice all these points, every coordinate has 3 added to it. Okay? All right. Any questions there? Again, you can use your graphing calculator. You can use your table and plot those points. All right, while I'm handing out today's assignment, I want you to go ahead and plot both those graphs on that grid there using your table off your calculator. So when you're going to graph this, don't be the person that just looks at the picture and says, I think, you know what, those are the pictures, so what I think I'll do is I'm going to go like, yeah, and, all right, and, all right. Okay, there we go. That's not what you do. All right, I want to see when you're graphing these, I actually want to see you plot points. Actually put numbers on your or put points on your graph so I can see them. Okay, that would be a better picture of that there, where you're actually plotting points. I can see the actual points you plotted. Okay, I'm going up by 1s there. The y-intercept of the graph of G is shifted 3 units up. The range, therefore, is also shifted 3 units up. So it's instead of y being greater than 0, it has to be y is greater than 3. The domain for both of those is all real numbers. Okay, the domain doesn't change, only the range. All right, you have your assignment.